Greetings and welcome to my new calculus channel. Yes, this here is me at age 41. So I've been showing you various photos and telling you a little bit about myself. That's what I looked like at age 41. Anyway, not about me this video. Perhaps another one in the future I'll speak a little bit more about myself. But in the previous videos we discussed definition 5 and 6, right? So now I just want to recap on definition 6 to tell you, just so that we can be fresh about what that was about. And definition 6 really tells us that ratios, magnitudes having the same ratio are called proportional. Okay, so it's not strictly speaking correct to say that. So the correct way would have been, and let magnitudes that are in proportion be called proportional. And so you'll see that in definition 7, we're told that for equal multiples, okay, so in other words, that means we have two ratios of magnitudes where in the one ratio, the antecedent is a multiple of the consequent, and in the other ratio, the consequent is a multiple of the antecedent, okay? And this is not saying that if we have these two ratios, that this ratio is greater than this ratio, as Professor David Joyce claims on his website, because a ratio cannot be less than or greater than another ratio, okay? That's very important. But a ratio can be equal or proportional to another ratio. Stop your video and think about this a bit, okay? So what is being claimed in this definition is this, and now think about this very carefully. If the magnitude W is greater than X, where this ratio is in proportion to this ratio, where W colon U is in proportion to X colon U, and by the way, U colon U is the assumed unit, then the relationship or the proportion between W and X is greater in the ratio W colon X, implying that the measure of W by X in W colon X will be greater than the measure of Y by Z in Y colon Z, okay? Very important. Now, all these previous definitions are important in trying to arrive at a very, very, very obscure definition, and a very hard to understand one that took me a very long time in the past to understand. And in fact, to be honest with you, I'm not so sure that that is exactly what is meant, but I'll tell you what I think it means, and then you can decide for yourself. So definition 8 says a proportion in three terms is the least possible proportion, or the smallest, or the minimum proportion, okay? So now this definition on its own is impossible to understand. One has to investigate its meaning within context of the other definitions and what Euclid has been saying. So the ancient Greek philosophers, one cannot be a mathematician, by the way, without first being a philosopher. That goes without saying. They had a habit of being laconic. So, I mean, you know, Pythagoras, for example, he's the originator of the quote which says, miles liga me pola loya, ala pola me liga. Okay, miles liga me pola loya, ala pola me liga. That means do not say a little with many words, but a great deal in a few. So I think, excuse me, I think here they said a great deal in a few. And now obviously to Euclid this was clear, but it's not clear unless it's taken within context. So what do I think? Okay, so here's what I think. Any ratio by itself may be insufficient to arrive at a measure. Why? Because it can consist of two equal aliquot parts, right? So if the antecedent is equal to the consequent, there's not much you can say about the measure or the understanding of proportion, right? So if you have three magnitudes in proportion, then you can get an idea of the proportion of each of the ratios. And now you may say, well, wait a minute, what if the magnitudes are equal? Well, again, I think that Euclid would have stated as much, but from a contextual point of view, use of the word minimum makes sense. And if you can think of anything better, I challenge you to write in the comment section what it means. And by the way, I've read what Thomas Heath wrote about it, and and all he wrote about it is a superficial understanding. So he didn't really explain this definition, and to my knowledge, no one else has. I'm John Gabriel. This is a new calculus channel. Till next time, goodbye.